All right, linear systems of equations with three variables. Example number 2, we went through, if you watched example 1, watch them in order. Can I say that enough? All right, because they build on each other. So we've got these three. We're looking for x, y, z, and ordered triple as we've talked before. So that would be the idea there. And again, you can label these equations whatever you want. I'll tell you a story at the end of this, all right? And you can hang around and watch it if you want. If you don't, you won't need to, about some of the interesting labels that people have given these. I'll be boring, A, B, C, all right? Like I said, I'll do the math, and then at the end, if you want to hear Grandpa's funny stories about the names people have given their equations, then you can hang around for that. All right, so A, B, C. So just like we said on the first example, my recommendation would be to take the top two equations, which I have very boringly labeled A and B, all right? I invite you to be, imaginative. You can call them Larry, Moe, and Curly. I don't care. All right, but 3x plus 5y minus z equals -2 is the top equation. And then the middle one is, I've written that too big. I can tell I'm going to run out of room. I'm going to squeeze this over again. Sorry. All right. I generally don't have this board space problem, but anyway, here we go. And then I'll quit whining about that, hopefully. All right. But I would highlight to you that we will get rid of z. Let's just do it. All right. Let's make this the kind of question we did on assignment 28. On 28, we didn't have z. All right, so let's get rid of z right at the beginning here. So that should be easy. We'll just leave that positive 2z. So we can just bring over this equation. And if that's positive 2z, couldn't we just multiply the top one by 2 to make that one become negative 2z? Remember, we're focusing on getting rid of z. We talked about how to eliminate a variable on assignment 28, so do that very same skill here. All right, so we now have 6x plus 10y minus 2z equals -4. All right, so there would be that one. And we add them down, 10x plus 9y, we got rid of z, and it equals -3. We know how to eliminate a variable, right? So we do that with the top two equations. Now we'll take the bottom two, B and C. I'm shaking these markers because I've learned that if you shake them, they're more vivid. So I'm trying to have a good marker ready to go here. All right, B and C. 4x minus y plus 2z equals 1, and then -6x minus 10y plus 2z equals 0. I would again tell you, in general, whatever variable you got rid of from the top pair, get rid of that same variable from the bottom pair. And so we'll get rid of z again. And it doesn't matter. You would hopefully note that all we need to do is multiply one of them by -1, and they'll have opposite signs, and goodbye z. So let's just say, for the sake of discussion, that we decide to multiply the bottom one by -1. And that'll end up with a plus 2z and a minus 2z. Yay! All right, so I'll transfer over that top one there of those two, plus 2z. Let's make that not minus 2z. Distribute a negative to every term in that equation. And now it becomes 6x plus 10y minus 2z, and 0 times anything remains 0. Multiply every term in that equation by -1. Combine like terms, and this is 10x plus 9y, z goes away, and it equals 1. All right. Again, the purpose, in my opinion, the strategy I like is to get rid of z so that you end up with two equations and two variables. You can take them off to the side and work them off over here on this board that you can't see. All right? I'm back. So, I would typically take those off there and work them, but I'm going to erase back here and bring it back this way. So, this will be, at this point, you're hopefully going, 2 equations that have x and y in them? Well, that's just assignment number 28, isn't it? Oh, this is so assignment number 28. So, we now pull this up over here. This one and this one. And we say to ourselves, I'm not going to leave this area. Just got a text. I hope that's my agent. All right, I'm not leaving this area until I know what the x and the y are equal. And then once I get them, I'll come back and find z. Just like we did on example number 1. Watch these in order, all right? So, anyway. You guys want to get rid of x or do you want to get rid of y? Well, I don't care. Why don't we flip a coin? Or I'm sorry, I don't know where things end up going. Can I? Oh, you. Yes, thank you so much. That's very kind of you. Really? A penny? Really? After what everybody else has been giving me? Are you sure you want to pass this class? Okay, well. Anyway, heads, x, tails, y. Hit the ground, catch it. I don't care. It's heads. I promise. So let's get rid of x. I've had people say, I wish I could get rid of my x. But anyway, I would hope that you would realize all you got to do is multiply one of these by -1 and make those x's have opposite signs. So how about we leave the top one as is, 10x plus 9y equals -3, and we'll multiply the bottom one by -1, and that would give us -10x, -9y equals -1. Yay! We got rid of x, right? 10x, -10x. That's all by design. Got rid of x. By coincidence, we also got rid of y. There's no variables left. Both variables eliminated. There's 0 over here. And -3 and -1 make -4. And 0 does not equal -4. That's false. Now, we've talked before, when we solve equations, and when we go through the process of solving, and we didn't know what was going to happen before we started, but when we go through that process and end up with a false statement, no variables, 0 equals a number that's not 0, doesn't that mean there's no solution there? And so that would be the point here. That would be the answer, is the fact that there's no solution. There's no solution. Acoustic version. I've had people say to me, and it makes sense, people go, wow, all that work to get no solution, that was kind of a waste of time. My response to that would be, and I know it's a stretch, but in math, if you set up some sort of mathematical problem, question, and it leads to no solution, let's say this was part of the design of a bridge, if it led to no solution, it's telling you that it's mathematically impossible to build that bridge the way you've designed it. I know that's a stretch, but that's just kind of the idea there. So, does that make sense? My engineer friend Kip, who designs bridges, if it's no solution, it doesn't work that way. You've got to change something in your design mathematically to make it work. Okay, I promised you can quit watching now. I promised you some of the fun names that people have given these equations. Maybe they're not so cool. I don't know, Do, Re, Mi, Larry, Moe, and Curly. All these things that come in threes. But one of my favorites all time, and this was a long time ago, so maybe the reference will fly over your heads. But many years ago, I was grading a paper, and somebody had labeled their top equation Rachel. Okay, just a name. And then their middle one, they had labeled Monica. Okay. And then the third one, they labeled F-I-B-I. And I'm reading that, and I'm going, Rachel, Monica, Phi-Bi. Rachel, Monica, Phi-Bi. I don't get it. I don't understand the reference. Rachel, Monica, Phi-Bi. This is years ago. All right? And I'm driving home from work that day, pondering, Rachel, Monica, Phi-Bi. What? Rachel, Monica, Phi-Bi. Rachel, Monica, Phi-Bi? This is a long time ago. And then I'm thinking, well, maybe these people were friends of this person. And then I went, friends? So if you're familiar with the old show Friends, there are characters on the old show Friends named Rachel, Monica, and Phoebe. And that's how this person apparently thought you spelled Phoebe, was Phi-Bi. So anyway, that's kind of one of my favorite ones. Rachel, Monica, and Phi-Bi. Have fun labeling your equations. You don't have to, but I suggest it. Let's have some fun. All right? Thanks. That, by the way, wraps up assignment number 29, and you'll do 4 of them. And I guess I should also mention, we still could have the infinitely many solutions. If you get a 0 equals 0 situation, that would have been infinitely many solutions. I should have mentioned that earlier before I told people they could quit watching, but if you kept watching, and look, it's the same interpretation as it was before. So again, 0 equals 0, true, infinitely many solutions. That could still occur. All right? Now we're done. I hope.